Stop the chit-chatting, at least I think it was Christian chit-chatting. All right, part one. Review. Solved. Number one, x over 4 equals 13 over 52. All right, we will do some of the math multiplying stuff together. What do I do? What's the process called? Cross multiply. When did you guys learn this? Do you know? It was not second grade.
It was like in probably last year or 7th grade or something.
Middle school? 6th grade? Middle school up.
Yeah,
all right. Shh. Okay. X times 52 is 52x. 13 times 4. Can you guys do that quickly? No?
No.
What's 13 times? What is it?
52.
52. And then what do I divide both sides by? 52. And gone. Oh, wrong one. I crossed out. Gone there. This one is definitely not. Well, it does reduce. I'm going to leave it there. What is it reduced to? 1. So it's not gone altogether where it's 0. It is a 1. X equals 1. All right. Number 2. X over 2x plus 1 equals 16 over 40. Okay, is this also a cross multiply? Mm-hmm. It is. Right here, when I cross multiply, what's x times 40? 40x. 40x. Now here is where kids fumble up. What do I have to, there's a special math word I'm looking for. What do I have to do here? What is it? Distribute 16 parentheses 2x plus 1. It's not just 16 times 2. It's 16 times the 2x as well as the plus 1. So do not forget you have to distribute the distribution property. 40x equals, what's 16 times 2x?
32.
Plus 16 times 1 is 16. And how do I solve this? What should I subtract, the 16 or the 32x?
32.
Yeah, I don't want to subtract the 40x this way. Why? Because I end up with what on the left side? Nothing. And I don't want to do that. So I'm going to subtract the 32x. Gone. What's 40 take away 32? 8x equals 16. What do we do? Divide by 16 or by 8? 8. Because it's smaller or because it's the coefficient of x? Coefficient of x. So what does x equal?
2.
Questions? We're good? Okay. Part 2, similar polygons. Okay, we're ready? 2 polygons are similar if corresponding angles are congruent. And there's more to it, but let's get that down first. 2 polygons are similar if corresponding angles are congruent. Have we seen that before? Corresponding angles are congruent? We have. For what type of polygons? What type of polygons? congruent polygons or congruent triangles? If triangles were congruent, were corresponding parts, like corresponding angles, were they congruent? Yes? So how is this different? Instead of, we're not dealing with congruent polygons, we're dealing with what? Similar. So how does it change? It's in the next piece here. Because when we're dealing with congruent triangles or congruent polygons, not only corresponding angles are congruent, but what else is congruent? Corresponding sides. Corresponding angles and corresponding sides are congruent. With similar polygons, yes, angles are still congruent, corresponding angles. And here's the next part. And if the lengths of corresponding sides are, and I haven't, I'll give you the last piece in just a little bit. All right, two polygons are similar if corresponding angles are congruent, and if the lengths of corresponding sides are, should I put the word congruent? No, because if I put the word congruent, they're not similar, they are actually congruent. They're equal, they're the same. All right, so what do I put? They are, anybody know what I'm going to write?
Proportional.
Proportional. All right, so key pieces here. Two pieces. Corresponding angles are congruent, and corresponding sides are what? Proportional. Not congruent, proportional. All right, so if that happens, the polygons are what? Similar, not congruent, similar. What kind of, like we know, you know, the translations, the transformations when you slide and reflect, what type of translation does the similar polygons? You guys have talked about it before. Starts with the D. Dilations. If you dilate, like if you have something like a zoom in on your camera, does it keep the image, just make it larger or make it smaller? That's what we're going to be dealing with. All right, so let's get a picture down. I'm going to draw a quadrilateral. I'm going to call this A, B, C, D. G, H, I, J. Okay. Now I'm going to put here that A, B, C, D is similar, so leave a space there, to G, H, I, J. What notation, what do I put here for similar? Do you guys know what it looks like? I'm going to put it in pencil because I do want to erase. Is this the marking for similar?
No.
No, that's the marking for what? Congruent. You want to make sure you're keeping track of your markings. Similar is a tilde sign. The top of the congruent marking, it looks like that. When you put that, that means they are similar. A, B, C, D is similar to G, H, I, J. All right, so like before, corresponding angles are congruent. That hasn't changed. So angle A is congruent with which angle? I'm looking at my statement here. With which angle?
G.
G. Angle B, according to my similarity statement, B matches with angle
H.
H. So can I put two markings here in the H? Yes. C, according to my similarity statement, corresponds with angle I, so they are congruent. And D corresponds with J, so they are congruent. Where did I mess up if I just mark it like this? Right, and we don't have, you can say, well, they look congruent, but we don't have enough information. That's not what I'm trying to say. So how many do I need in corner D? 4. 1, 2, 3, 4. 1, 2, 3, 4. All right, so that first piece does not change. Now, why are these two polygons not congruent? Because corresponding sides are not what? Congruent. Can you see that? That AB does not equal GH. Do you guys see that? I mean, you can see it, yes or no? GH is bigger than the AB, so they're not congruent. They are similar. All right, so how do I write out these sides are proportional? I need everybody paying attention. Are you ready? Okay, so we need to make sure we have a handle on this. Proportions means we're making what? A bunch of fractions. 1, 2, 3, I'm going to make 4. All right, now I'm just going to go in order. I'm going to start with AB. AB over what's its corresponding side over here? GH. They're not equal, but they're corresponding. Do you agree? AB over GH will always equal, and you just keep doing it back and forth. So this first one, I'm going to write BC. What side over here corresponds with the BC? HI. I'm going to stop here, and I'm not going to write any more just yet. So if I had lengths here, if I gave you proportional polygons and actually gave you numbers, and I said these two polygons are similar, if you took AB over HG and then BC over HI and did any reducing, should they come out to be the same? Yes. Yes. If they do not, then they are not similar polygons. So this statement has to work. All right, let's keep going. What would be the next one? If I'm going in order A, B, B, C, what would the next one be? CD. And then you'd match it to the other one. If I'm looking here, CD matches with? IJ. Could you also look at the picture? Yes, the picture is easy to use here, but if it's like rotated and it's hard to tell, can you always just use your statement here?
Yes.
AB, GH, BC, HI, CD, IJ. What's the last one here?
DA.
DA. Now if I'm using my picture, DA and
JG.
JG. If I'm using my statement, DA and JG. All right, so both of these have to work. In order for this to be true, this has to work, as well as corresponding angles are what? Congruent.
Yeah.
Corresponding angles are congruent. Corresponding sides are, what's the word, not congruent? Proportional. Corresponding sides are proportional. Corresponding angles are congruent. All right, questions? Okay, I'm going to move it over here. Scale factor. Okay. What is scale factor? It's a ratio. It's a ratio of corresponding sides. It's a ratio of corresponding sides. Daniel, are you taking notes with us? All right. So I'm going to draw two triangles. A, B, C, X, Y, Z, and I'm going to label sides. Are you ready? Actually, I'm not. I'm going to label angles first. 1 in A, 1 in X, 2 in B, 2 in Y, 3 in C, and 3 in Z. Are these two triangles similar? Have I given you enough information to determine if these two triangles are similar? How many, correct, Christian, how many pieces of information do we need? 2. Sides are proportional and angles are congruent. Did they give us 2 or just 1? Which one did they give us? Corresponding angles are congruent. Is that enough to say they're similar? No. What else has to happen? Corresponding sides are proportional. Okay, so I'm going to give you numbers. 15, 20, 25. This one is 6, 8, 10. Got it? All right. Are the two triangles similar? Are you guys okay with using that notation? If you are not, what do you write out instead of this squiggly tilde marking? Similar. Are the two triangles similar? So I'll put it here for you now so you know for next time. Similar. Are the two triangles similar? All right. Do we have the angle matching piece down? Yes? What's the only thing we have to check is if the corresponding sides are proportional. Now, okay, well actually, it is easy here to figure out where your numbers go, but let's say angle markings were not given, or it was rotated around. Go in order, like for example, start with your smallest or your largest. What's your smallest number here? 15. And then go to your other triangle. What's your smallest number here? 6. Go to your medium number here. What's your medium number? 20. What's your medium number here? 8. What's your large number here? 25. And your large number here? 10. Now, we could have done that other ways. We could have looked and said, oh, single to double, single to double, double to triple, double to triple. But if they tell you something similar and don't have the angle markings in and things have been rotated, matching like small with small, medium to medium, large to large is a good tool to have. Right, yes?
Will they only do this on scale factor?
When we're looking for scale factor, yes. All right, so these all have to equal, so let's reduce each one. What does 15 over 6 reduce to? 5 over 2, because you divided top and bottom by 3. This one divide top and bottom by 4. What does that give me? All right, last one, divide top and bottom by 5, and what do we get? Are they all the same? So are the two triangles similar?
Yep.
Yes. Next question, what is the scale factor of triangle ABC to triangle XYZ? Yes. Yeah. What is the scale factor of triangle ABC to XYZ? Now, when they ask you for scale factor, they will ask you from one to the other, from small to large, from large to small. You have to know which number goes on top of your fraction. So if they're saying ABC to XYZ, which number is going to go in the numerator? ABC, one of the ABC triangle sides, and which one's going in the denominator? XYZ. All right, so we already have it here. We already have all the work, but I'm going to do it again. Pick a side. It doesn't matter which side. Since we know it's similar, it doesn't matter which side you pick. Pick one. AB, the 15. Now, when it's been rotated or the angle marks are not given to you, how do you know to pick the 6, the 8, or the 10?
The 16.
Because 15 is the smallest. Which one's the smallest over here? 6. If you had picked 20, which is the medium, which one would you pick over here? 8. If you had picked 25, because 25 is the largest, what would you pick over here? 10. What does 15 over 6 reduce to? Is it the same number we got over here when we reduced?
Yes.
Yes, so this here is the scale factor. Are we ready? Okay. List the pairs of congruent angles and the extended proportions. Okay. Yes. I didn't do a very good job on this one, but imagine that they are similar. All right. I'm going to write here, oh, let's label them R, S, T, V, D, E, F, G, R, S, T, V, D, E, F, G, and you're going to write here that R, S, T, V is similar to D, E, F, G. Okay, this is given information. You don't have to be like, how am I going to know that? This will be given. Okay, I'm going to start you off. It's going to look like the one we did over here. Only thing is, instead of marking your angles in here, we're going to write them out. So I will start you off. Angle R is congruent to which angle?
D.
D. Now don't just assume it matches over. Look in your congruent statement here. Does R and D match up?
Yes.
All right, keep going. Okay. All right, S is congruent to what?
Angle E.
Angle E, T, angle E, angle T is congruent to angle
G.
T and F.
Oh, F.
Yeah, right here. Do you see it? T and F. And then V and G. Okay, so you got it?
No, I must have done.
Okay. Down here, you're going to have what looks like this. So I will start you off. This is our first set of answers for the congruent angles. Now extended proportions. I'll start you off with, let's do RS just to match this. RS will go over what? RS with DE. So I'm going to just color that in. RS matches with DE.
Is this still scale after?
No, this is an example from homework. RS over DE, write the rest of them. There's 3 more. I know that ST matches with EF, looking here and here, yes or no? So what goes in the denominator of ST? EF. And we know that TV matches with which one? FG. They're not congruent, but they have the extended proportions. The sides are proportional. All right, TV with what? FG. And VR with GD. Okay, questions here, yes or no? You ready? Okay, number 2. Triangle NOP is similar to triangle WXY. Find the following. Okay, so let's get the picture down. I'm going to draw 2 triangles. I'm going to call this NOP, WXY. I'm going to call this here 58 degrees. This one up here is 49 degrees. This is this length here is 4. The length on XY is 10, and WY is 12. Okay, we ready? Part A, find the scale factor. Oh, let me write more. Because you need to know which direction you're going, of triangle NOP to triangle WXY. What number is going on top, the NOP triangle or the WXY? So top and the bottom when I make my scale factor fraction, yes or no? All right. Now when I find my scale factor, it has to be corresponding sides. So for example, can I use, or can anybody tell me why I'm not going to use the 12 when I'm looking for my scale factor? Good, because WY corresponds with NP, and NP doesn't have a side. What is the only side I have over here? OP, which is 4. So that's the only number I can use. I'm forced to use the 4. So what's my fraction going to be? 4 over 10. Gentlemen, I need your heads up off the desk. And Peyton, can you nudge him and tell him to take his earbuds off? Head up off the desk, and you're listening. All right. Okay, so what do we write? 4 over 10 equals what? What is it? 2/5. And I forgot to say it earlier. Another way to write this is what? 2, 2, 5. Both are correct. You don't have to write both of them, but they are both correct. All right. Questions before I move on to part B? Yes. Yes. Measure of angle X. All right. What do we have? Angle X is here, and X, according to this, X corresponds with? O. And do we know O? 58. So 58 degrees. All right. Part C, angle Y. The measure of angle Y. According to my statement, what does Y correspond with?
B.
With what?
P.
P. And did they give us the measure of angle P? Darn it, but can we find it? Yes, these two add up. 49 plus 58 plus angle P equals what? 180. Can you guys find that now? Add and, you found it already? What is it?
73.
Can you tell me first what 49 plus 58 was?
107.
107 plus angle P equals 180, and then you minus the 107 and got what? Angle P is 73. So is angle Y 73 degrees? Yes? All right, letter D is asking us for WX. What are they asking for when they write it like that with no bar at the top? The length. What's the length of WX? Did they give us a length here? No. Let me make sure I'm asking in the right order. WX. Oh, you know what? There was one other number I did not give you, and I apologize. I should have given you this one here. So going back to our scale factor, could I have used the 6 to find the scale factor?
Yeah.
Could I have? Because I have to use corresponding sides. Does 6 have a corresponding side over here? No. The only one that has corresponding sides that they give you are OP and XY. So am I forced to use the 4 and the 10? Yes or no? All right. I'm going to use a letter here just so I have something to call it. I'm going to call this letter C. Now when we set up our proportions, what am I trying to solve for? I'm trying to solve for the WX. So I'm going to go C over 6, I'm sorry, 6 over C equals what fraction? 6 over C equals
2 over 5.
2 over 5. Where is he getting the 2 over 5 from?
Scale factor.
Scale factor. Now, if you don't want to use the scale factor and you just want to use the picture, can you say 6 over C is 4 over 10? Would you still get the same number? If you think, well, that's the way my brain's going to process this, I'm not going to think to use a scale factor. I'm going to look at my picture and say match, 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 match. 6 over C, 4 over 10. Will you work it out that way and see if we end up with the same answer? I'm going to work it out this way. We cross multiply. What does that give me? 30 equals 2C, and divide, what does that give me?
C was 15.
All right, did anybody work it out the other way? Okay, we'll try the next one that way. A, B, C, D, A, B, C, D. E, I want you to find NP. All right, where's NP? Let's call that a letter. I've already used C, and I don't want to use X or Y. Do you guys want to call it A? Yes or no? Yes? All right, so what is my fraction going to be? Should I put, if I'm going from small to large, and my scale factor went from small to large, does it matter if I do A over 12 or 12 over A? It matters, because I want to be consistent. So what goes at the top, the A or the 12? A. So A over 12 equals your scale factor or 4 over 10. I challenge some of you guys just use the scale factor like we did over here, the 2/5. I'm going to say, hey, I'm not going to use the scale factor, and I can see A over 12, 4 over 10. All right, cross multiply. What's A times 10?
10A.
10A, and 4 times 12 is 40. 40 what?
8.
8. Divide both sides by 10. Anybody know how to divide by 10 easily? A is you either reduce your fraction or you write as a decimal. You choose decimal or fraction. Decimal. This is 4.8. Did anybody use 2/5 and get the same answer? Did anybody use the 2/5 and can't tell if they got the same answer? Nobody used it? Nobody took the challenge? All right, does it make sense? Yes?